The purpose of this video is to complete our Day 6 Innovative Classroom activity, which involves rational numbers. Now, just to review our standards, students can pause this and read this. Our I can statements are I can find and position integers and other rational numbers on a horizontal or vertical number line diagram. Now, in our previous video, Day 6 video A, we did practice finding positions of integers and other rational numbers on horizontal and vertical number lines. In this video, video B, we will fulfill this I can statement. I can find and position pairs of integers and other rational numbers on a coordinate plane. Now, this is an example of a coordinate plane. Now, I should have a little arrow here to show that this is indeed a line that can go on indefinitely. This is an example of a coordinate plane. Now, all the planes I've seen before, they usually have the y-axis coordinate numbers on this side, but this one has the numbers on this side. I don't really think it matters for our purposes today, but I have seen it on this side. I just want my students to be aware of it. Now, this is the x-axis, this horizontal axis, which we are used to seeing in our number lines. This is the x-axis, and this is our y-axis, this one that goes vertically. Now, one of the things I will point out is the 0, the point of origin, is where the two lines intersect. Now, this 0 can stand for the 0 on our horizontal line as well as on our vertical line. Now, when we look at a number line, all the numbers to the right of 0 are positive. All the numbers to the left of 0 are negative. When we look at a number line, all the numbers above 0 are positive. All the numbers below 0 are negative. And one of the things I do want to point out is the farther you go right, the greater value your numbers have. The farther you go left, the least value your numbers have. When you go up into the positive area, the farther you go up, the greater value your numbers have. The farther you go below 0 or away from 0, the less value your numbers have. For instance, -6 is less than -5. When it comes to terms of absolute value, like this being absolute value, we know that -6 is 6 spaces away from 0. But when it comes to actual value, when you look at the number itself and not absolute value, -6 is worth less, is smaller, is less than -5. So if you ever come across comparing rational numbers, and that will be found in our Day 7 for my students, just to give them a heads up, the larger your number in the negative area, the smaller value it is. When it's positive, though, the larger your number, the greater value it is. Now, when you're looking at a coordinate plane and you want to list your coordinates, it's a lot like the game Battleship. I'm sure a lot of you kids have played Battleship. You might have seen the movie, and that's where a game where you put a plastic ship somewhere on a grid, and then your opponent has to guess by using coordinates where your ship is, and they might say things like B2 or something like that. With this coordinate plane, our numbers that are on the x-axis will be listed first, and our numbers that are on the y-axis will be listed second. Now, this is pretty much how that will look whenever you have to give coordinates on a coordinate plane. You're going to have usually parentheses. You'll have x, comma, y, close parentheses. Now, I'll do a couple examples with you. Let's say that I wanted to know where -4 by +4. Those coordinates tell me that here's my point of origin, and I'm going to go in the negative area. I'm going to go over to the -4, which is right here. Then my y-axis coordinate is positive 4, so I'm going to go up. And I'm going to go here, and right here is where they would intersect. Now, I know my students are used to using multiplication charts and things, and they're used to looking for where numbers intersect. So hopefully this won't be too much of a stretch for them. Now, this right here is where negative 4 by positive 4 could be listed. Let's do another one. This time, I'm going to go ahead and put negative 7 by, we'll say 3. Take a moment to see if you can figure out where that would go. If you need to, pause the video at this point. Okay, assuming that you have found where those two coordinates will meet. Here is our point of origin, the 0. Let's go over to negative 7 right here. And then let's go up to where positive 3 is and put our point. That's where negative 7 by 3 can be found. Okay, let's look over in this quadrant. Now in this quadrant we have, let's see, I'm going to start with positive 5 by positive 3. Now this positive 5 tells me on my x-axis I'll need to go here. And then I need to go up because I have positive 3 on my y-axis and put a point right here. So this is where 5 by 3 will be located. Now, ordinarily, this part here that I have written would not be on your coordinate plane. I just don't have enough room for a scratch area to put that. But just be aware that these would be on a separate sheet of paper, a separate area. Let's do another one. This time I'm going to this quadrant. Let's say that I need to find out where 4 by negative 6. 4 by negative 6. First thing, I would go over to this 4 on my x-axis, and then I would go down to negative 6, which is right here, and put my point. And so here I have 4 by negative 6. So that's where that would be. And I'm going to do one more in this quadrant just so I can say I hit them all. This time I'm going to need negative 7 by negative 5. Negative 7 by negative 5. Now we went to negative 7 before. It's right here. Now I need to go down to negative 5, which is right here. And I'll put my coordinates here. Negative 7 by negative 5. Now one of the things I want to point out, when you're in this quadrant, both your x and y coordinates are positive. When you're in this quadrant, your x quadrant is positive, but your y coordinate is negative. Over in this quadrant, both your x and your y coordinates are negative. And when you're in this area, your x coordinate is negative, but your y coordinate is positive. Now I'm going to clear my board and put another one up there for you just to see if you can find some of these on your own. This time though, instead of putting coordinates, I'm going to put points, and you tell me what they need to be. Okay, so I'll go ahead and put some points, and then you tell me what quadrant goes with those points. Okay, I put a few points on this coordinate plane. I put point A, point B, point C, and point D. What coordinates go with those points? Now, just a friendly reminder, you want to start with your x-axis first, and then the y. So at this time, you might want to pause the video and see if you can figure out those coordinates. Okay, assuming that you have paused the video and worked out those coordinates for yourself, let's go ahead and see how you did. We'll do A first. Now the first thing I want to do is see where A is on my x-axis, and it looks like it is at 8, positive 8. Now y-axis shows it's at positive 6, so 8, 6 are the coordinates for A. For B, we'll go back over to the x, and it looks like it's 5. And for my y-axis, I'm going to go down, negative 4. So 5, negative 4 are the coordinates for B. For C here, let's see where we went on the x-axis. All right, negative 5. And it looks like we went down to negative 2 on the y-axis. Okay, and on this one here, it looks like we went over to -9 on the x-axis, and we went to 7, +7 on the y-axis. So that's how you find rational numbers on coordinate plane. Now, just to recap rational numbers and what they are, rational numbers are any number that can be written as a ratio, as a fraction. And all these coordinates can be written as a fraction. For instance, when I have 8, I could simply go ahead and just say 8/1. That is a fraction, that's a ratio, and that makes it a rational number. 6, that could simply be 6/1, making it a rational number. 5/1, and then -4/1. Now remember, anytime you have a fraction where the numerator is a number above a 1 for your denominator, you're going to have a whole number as your answer, and it's going to be whatever your numerator is. Due to the multiplicative identity of 1, being anytime you multiply a number by 1, your answer is going to be the number. Your product is going to be the number you start out with. So that's what makes these rational numbers. And 5/1, 2/1, -5/1, -2/1, -10/1, and -7, and +7/1. Okay, I hope that this video helped you understand how to find coordinates on a coordinate plane, and be sure to complete your accompanying activities that go along with your innovative class activities. Thank you.